In this demonstration, we're going to be talking about the last thing that there is to calculate in a series DC circuit, and that's power. You can use any one of the three power calculation formulas to figure out power at all points. And just like the voltage in a series circuit, the total power is equal to the sum of the individual powers. So what that means is that the power at R1 plus the power at R2 is going to be equal to the total power. And you can calculate the individual powers for R1 or R2 or calculate your totals using any one of these three formulas. As long as you have two values, it doesn't matter which formula you use, your answer will come out the same. And you can also prove your answers by adding together R1 and R2, and they should equal your value that you calculated for your power total once you've done all of your calculations. So we have a total current flow of 2 amps, a source voltage of 48 volts, and a total resistance of 24 ohms. You can use any one of these three values to calculate your power total. So we'll use this formula first. The power is equal to I times E, or your total power in this case is I total times E total. So write that out real quick. Your power total is equal to the I total, or your total current flow, times your total voltage, or your source voltage, which is 2 amps of current flow, times your source voltage of 48 volts, which will give you a total power of 96 watts. So we solve for the total power. Now we need to calculate the power at R1 and at R2 also. So I'm going to use a different formula for the power at R1, and I'm going to use I squared R. So we can just punch in the appropriate values there. So calculating the power at R1 is I squared times R1, or 2 amps squared, times 12 ohms, and that will equal 48 watts. And for the power to R2, I'm going to use the last power calculation. Don't want to do voltage, want to do power. So we cover up the power, and that's going to be E squared divided by R. So the power at R2, using the last formula, will be E squared divided by R2. Now you got to make sure to use the appropriate values because it's the voltage drop at R2. So we're going to be using this value. So it's going to be 24 volts squared, divided by 12 ohms. Once again, just making sure to use the appropriate values for your calculations. And if you plug that into a calculator, it should be 48 watts. And like I had said before, the total power is equal to the sum of all your individual powers in a series DC circuit. So you can prove this power total is equal to the power at R1 plus the power at R2. And I think that we can easily prove that the total power of 96 watts is equal to the 48 watts at R1 plus the 48 watts at R2.